Hello everyone. Today I want to talk about HealthEye, an IoT system that allows you to monitor the amount of people and social distancing violations in a certain area. This was created by Vincent, Shelley, Joshua, and me, Chumbul. The greatest problem of our world today is COVID-19. Although we all know the solutions to end COVID is social distancing, it's hard to do it because of the lack of monitoring and the confusion around what space are safe to be in and when. That is the main reason why we create HealthEye. Our goal is to solve those two problems. One is to create a robust way to monitor social distancing, and the second is to provide information regarding COVID safe place. Our solution is to utilize computer vision and machine learning to analyze cameras to detect people in a given area and the number of socially distant violations. Uh, and we extrapolate on historical data using time series analysis to forecast future COVID risks.
To display the information and data we gathered, we use React.js to construct the UI and web page, and the Python Flask framework for the server backend. To serve the final product, we use Azure App Service, which allowed us to serve our website in a simple and a quick manner, without having to worry about the details with server configuration.
To analyze the images and videos and detect the people, we used Azure's Custom Vision API. Azure's Custom Vision API really helped us in speeding up the process in detecting people, as all we had to do was just input training images and let it run by itself. We didn't have to necessarily worry about the whole neural network or the artificial intelligence programming that went behind the scenes, as Azure takes care of most of that stuff. We decided to use Azure's custom Vision API rather than the regular Vision API, as as we wanted to retrain the model even more and make it so that it detects people further away. While it is not exactly perfect, it is we hope to refine it in the near future. To combine everything together, including the Raspberry Pi, the web page, and the custom Vision API, we wish to deploy these as IoT Edge modules and then have a Raspberry Pi connected to the IoT Hub. These two services provide great scalability for our IoT system, which is why we had previously planned to do that. However, because of time constraints and some errors setting up our Raspberry Pi 4, we switched to a more basic plan, where we make calls to our Vision API and send them directly to the database via Azure Functions. We use Azure Functions as our bridge when requesting and putting data in the database. This allowed most of our local dev to be only about the camera input, social distancing calculations, and website development, rather than the whole server side and backend system. So let's give a little demo of this system. We have our website pulled up, and our camera, which is attached to our Raspberry Pi. We have an Ethernet cable that is currently connected to our computer so that we can SSH into it and then run the command to start the visual analysis. Theoretically, you only need to start this one time. So we just stand in here, let it capture us. And then if we go back to our page and refresh it, the current time is 5:13. It will show us that there is only one person here and the location name is home. So besides camera streams, we can also analyze video streams as well. Here we see that we have a window showing all the detections in the terminal. It also shows how many people there are and how many violations there is. And when we go back to our website, we can enter a time. So our current time is 6:54. And when we refresh, we'll be able to see a marker indicating that there are some people there. We click on it. We can see that there are 8 people with 8 violations. The location is at home. We can fast forward a few seconds. See, that's 4 people in 1 violations. Thus, you can see how many people there are over time. Thanks for watching. We hope that you enjoyed our project as much as we enjoyed learning about Azure. You can find our project down in the GitHub link and the dev post. Thank you.